This video introduces one-to-one functions. A function f from a to b is said to be one-to-one if this condition holds. This condition says that if f of x1 equals f of x2, then that must be the case that x1 equals x2. What this means is, this says that f of x has unique outputs, unique y values. Let's see examples. So the function f of x, let's say 3x plus 1, is one-to-one. How can we tell? Let's suppose that f of x1 equals f of x2. What this means is that 3x1 plus 1, that's the output of the function when I plug in x1, that should equal 3x2 plus 1. Then you could subtract 1 from both sides, you could divide by 3, and we can conclude that x1 has to equal x2. So that's why this function is one-to-one. Why don't we do an example of a function that is not one-to-one? So the function f of x, let's say x squared plus 1, is not one-to-one. Why is that? Two different inputs can have the same output, so the output values are not unique. In particular, you could plug in -1 for x. If you plug in -1, you get 2. And that's the same value you get if you plug in +1. So plugging in two different values gives you the same output. That means the function is not one-to-one. If you want to see this second example graphically, you could draw the graph of x squared plus 1. That's the graph of x squared, just shifted up 1 unit. So we get a parabola that looks like this. If I plug in -1 and if I plug in +1, I get the same height. So I have two places on the graph that are the same height if the function is not one-to-one. Writing down this fact more carefully, I could say that if f is one-to-one, then the graph of f passes the so-called horizontal line test. The horizontal line test says that any horizontal line must intersect the graph of f in at most one place. So if I have the graph of a one-to-one function, maybe there's an example, any horizontal line I draw intersects the graph in at most one location. This is an analog to the vertical line test. Every single function must pass the vertical line test, meaning that any vertical line intersects the graph in at most one location. But to be one-to-one, it also passes the horizontal line test. Let's finish with an example. So the graph of f of x equaling 1 over x looks like this. So we've seen this basic graph before. It goes like this. This graph passes the horizontal line test. Any horizontal line you pick intersects the graph at most one place. So therefore, this passes the horizontal line test, and so f of x is indeed one-to-one. Okay, wonderful.